Okay, so I'm live, right? So I'm just live, just wait. So I'll just quickly share this video on Discord. Okay. After that I'll start today's video. Codechef. By the way, am I perfectly visible and audible? Can anyone just confirm? Someone just confirm whether I'm perfectly visible and audible, okay? So this is the sound of the fan is too loud, right? Just wait, okay, just wait. I'll just put it a little bit slow. Now I think it's perfect. So this is the sound of the fan is too loud, right? Just wait, okay. I'll just put it a little bit slow. Now I think it's perfect. Okay, so let's start with the video, okay? Or maybe I just need to let's start with the video. Okay. So let's get on to the first problem, okay? That is range minimize. People who are in the lobby, just write a hi or whatever you can, so that I know that you guys are there, okay? Because it should be kind of interactive. So whenever I'm doing something, it should be kind of interactive. I'll just also share the code of the Discord, okay? So you guys can click this thing on the comments, and this is the code of this is the code of the Discord, okay? I'll just pin it. Discord and Insta. You guys can join it. Okay, so the first question, that is range minimize. It tells us that you're given an array A containing n integers. Okay, you can delete at most 2 of its elements. Right. Now, since you can delete 2 of its elements, so we'll just go through the whole question first, and we have to find the minimum possible value of maximum A minus minimum A. In other words, the range of A. Okay, after the deletions. So what basically you are given is that you can. Now since you can delete 2. Okay. Now since you know that you can delete 2 elements only, so basically let's think it this way. Okay, just think it this way, that you got an array. Okay, and you have to find the range of the array, but you can delete 2 elements from it. Okay, you can delete 2 elements. Now whenever you are deleting 2 elements, so let's say if the array is now sorted. Okay, if the array is now sorted and you're checking this element, you're deleting this and this element, so it doesn't have any impact on the range, because the range remains same. Okay, because the lowest will be over here and highest will be over here, and the range is basically the subtraction of the highest minus lowest. So basically that will be the same, so that it won't be high. 3. Okay, that's good. So basically, see, one thing that you can see is, now since this doesn't affect the range, that the extremes, so it is very much evident that we have to, like whenever we are deleting something, it has to be something from the ends, from the extremes. Okay. Now what does the extremes means? The extreme means this element, this element. Okay. Now what we can do is, it is very simple. You can just remove the last and the first, or the first and the last elements. Okay. And you may say that it is going to give you the best answer, but it is not so, because if you're going to have an impact on the range, it means by deleting any two elements. So what you can do is, you can either delete the last two elements. Now the range becomes like this. Okay. If you delete the first and the last element, then the range becomes like this. Okay, so are you going to solve up to division 2 D and E? See, I haven't gone through the problem E, but I am going to solve till D. Okay, till D, I think it is till D only, right? If D is this problem, this completion easy. So yeah, I have done till completion easy. Okay. I also checked like whether this code works for completion hard or not. Okay, so you don't need to worry much about it. Okay, so basically what you can do is, you can either delete the last two elements, or delete the first and last elements, or delete the first two elements. Okay, now for doing these, only these three operations, only these three cases are the ones where your range is differing. Okay, and we know that we have to minimize the range. So among these three cases, okay, from among these three cases, that is this case, and this case, whichever gives us the minimum range, we have to keep it. So let's go with the code quickly. Okay, so I think you guys won't be able to see it. Now you can see the code. So I'm taking this is the number of test cases, and for every test case I'm taking the value n, and I'm just inputting the array in it. Then I'm sorting the array, as I told you, because we are just interested on the range. So we have to sort the array. Now if we are taking out the first two elements, that is this blue box, okay, this blue thing, okay. If we are going for the blue thing, that means it is going to be the last element minus the third element, right? This, the last element minus the third element. Okay, so basically that is it. You can see that I have like taken away the last element minus the third element, and then comes the red box. Okay, the red box, which is the second last element minus the second element. Okay, that is the second last element minus the second element, and finally it comes the orange box, that is the third last element minus the first element. Okay, and so basically this, and you can see that I have taken the minimum, that is whichever is yielding the minimum value for the answer among these three ranges, that is going to be our answer. Okay, that is going to be our answer. See, I can't see how many people are watching. Okay, from my showing that there are 2 people watching. So whoever is watching this, because I know one person who is watching, I know who is it. This is Jeet, and the other person who is watching it, just like write hi or something, okay, so that I know that you are watching it. Okay. And anyways, people who have joined, just like my video if you find it good, and you can also subscribe my channel. Okay. So that's it. Okay. So if you like run it, you will get to see that it's an accepted code. Okay. You'll see it's an accepted. So if this is clear, then I'll go to the next problem, that is maximize Hamming distance, right? So is this clear? Is this clear? Just tell me if this is clear. Okay, then I'll go to the maximize Hamming distance problem. And guys, I have done maximum Hamming distance. Then, oh, this is the anti-palindrome. Why is it showing cross though? I don't know. Like I think it didn't get updated. So yeah, this is the anti-palindrome question, and this is completion easy. Okay, till completion easy, I'll just, yeah, okay. So let's go to the next question. Okay, so maximum Hamming distance. So what is the maximum Hamming distance? Hamming distance, it basically, first you need to understand what Hamming distance is. Okay, the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. For example, the Hamming distance between this and this is 2. Why? Because for the first position it differs, so it provides one Hamming distance. For the second position it is the same, so no Hamming distance. For the third position it differs, so one more Hamming distance, and for the last position it is same, so no Hamming distance. So there were two positions where it differed, so that is 2. So basically it is like how many positions it differs. For all the possible pairs you have to maximize the Hamming distance. Okay, now since you have to maximize the Hamming distance for all the possible pairs, so what you can do is, for every, now okay, now one more thing that was given in the question, that is the strings are not only represented as 0 and 1, some of them are question mark, and you place this question mark with either 0 or 1, whichever is going to maximize it. Okay, whichever is going to maximize the Hamming distance for all the pairs. So let's get it with the Hamming distance. Okay, so right, for now you know what basically Hamming distance is, right? Now since you know what Hamming distance is basically, now what you need to more focus on is the fact that how to maximize the Hamming distance for all the pairs. Okay, now let's say if there, let's say we are going to first consider that all the positions for the first, all the elements, I mean all the strings for the first position it is question mark. Okay, so there, let's say there are 4 strings and the first position is question marked. So what you can do is you can either have 0 and 1, right? So what will be the count of 0 and 1? So the count of 0 will be, let's say 1. Okay, so one possible value, it should be, it can be either 1 comma, not 1 comma, so 0 can be either 0, there will be no zeros and all of them will be 1. Okay, or 1 0 and 3 of them are 1, or 2 zeros and 2 of them are 1, and 3 zeros and 1 of them are 1, or 4 zeros and none of them are 1. Okay, so these are the possible values, right, that we can have. Now you have to determine what should be the Hamming distance just considering that element. Okay, so if all the 4 positions are same, so the Hamming distance will be 0, right? It will be 0. But if 3 positions are different, okay, if 3 positions are different and one position is same, it doesn't matter whatever it is, so the Hamming distance will be 3, right? But if 2 positions are different, so the Hamming distance will be like there are 2 positions. Okay, so basically for every of these 2, of this 2, for every 2 you can have 2 which are different. Okay, which make 2 into 2 4, right? Sorry, 2 into 2 4. Clear? Just one reminder, if you're new to this channel, just subscribe my channel and like this video, give a thumbs up. If you like, and whenever I say clear, okay, just respond like yep or yeah, clear, something like that, so that I know that. So that, like, if it's not clear, just be very transparent with me that yeah, it's not clear, can you explain it again or not? Okay, something like this. So basically we can say one thing, that these numbers are basically the multiplication of these two numbers, right? 3 and 1, 2 and 2, then 3 and 1, it will be 3, right? So basically the numbers of zeros and numbers of ones, if we multiply them, it is going to tell us how many what is the Hamming distance. Okay, what is the total Hamming distance between them? Now since we know that this Hamming distance is like this, so we can see one thing, like we know this, right? We know this, like if we want to maximize x into n minus x, okay, if we want to maximize x into n minus x, so the value of x should be n by 2, right? It can be proved by using the maxima law, by by differentiating it and checking out equal to 0 and then check the maxima, so it can be proved using that. So basically x equal to n by 2 is the maximum. Okay, in order to maximize this, you have to make x equal to n by 2. Okay, Now let's say this question marks, okay, this question marks that were given. Now some of the question marks are filled. Okay, some of the question marks are now filled. Okay. Now we know that if we want to make it better, so we have to make it 2 comma 2, right? That is n by 2 and n by 2 comma n by 2, right? Now if we want to make it n by 2 comma n by 2, so I have to replace this question mark with 0, right? So this is a valid thing, right? You can do that. But what if this was also 0 and this was also 0? So in that case, you can't make it n by 2 because zeros, the number of zeros are already greater than n by 2, that is greater than 2. So you are left with only 1. So you have to place the 1 over here only. Okay. So basically your aim is to make, like, divide the zeros and ones equally. Okay. That is your basically aim. Now for every specific position, you have to divide the zeros and 1 evenly. Okay. So like, is this part clear? Like till this, is it clear? Just tell me if it is clear. Okay. There are 5 people who are watching this. Again, just subscribe my channel. It will be better for me, and like this video. Okay. So tell me, okay, is this clear? If it is not clear, then I'll explain it again. Okay. Okay, so since there is no response from you guys, so I'm just assuming that it is clear only. Okay. Or am I lagging though? Am I lagging? I don't know. Okay, so since there is no response from you. No, I'm not lagging, right? I'm not lagging. So guys, just be responsive, okay? And people who are new, just subscribe my channel. It will be helpful, okay? So what I'm doing is basically I'm taking the inputs n comma m, okay? N is the number of like, not the number, n is the length of the string for every specific string, and m is the number of strings. So for every string, I know that since it is going to be zeros and ones, so this is going to store the frequency of zeros, okay? Zeros. And this is going to store the frequency of ones, okay? And then I'm going to take this string is just to, like, for every specific I'm just taking the string input, okay? And for every string input, I'm checking for all the positions, and for all the position, if it is a 0, I'm going to, like, give this value a plus plus, or if it's 1, so this value a plus plus, okay? So for every specific position, now we know how many zeros. Can you explain 1 second of how to maximize? Sure, I'll explain that. So what I was telling, that basically, let's say if there are, like, n number of question marks, okay? I mean, let's say not question marks, if there are n number of positions, okay? And you can either put zeros in them or ones in them. So if you want to, now we know one thing, that the Hamming distance is basically going to be the number of zeros into the number of ones. So basically number of zeros into number of ones, right? Now since it is going to be the product of number of zeros and numbers of ones, so it basically means that, let's say if the number of zeros is x and the number of ones, then the number of ones will be n minus x, right? Because there are n total. Now if we want to maximize this x into n minus x, then we know that the formula is x equal to n by 2, right? Because obviously you can see this example also. So this example, n is equal to 4. So we have checked for all the values of x, and it is shown that x equal to n by 2 is giving us the maximum result, okay? So this is it. And if you're talking about the number of zeros into number of ones, why is it so? Then I can also explain you, because for every specific zero, the number of ones are the positions which are differing, and Hamming distance means the differing positions, right? So let's say if there is two zeros and two ones, so basically for this one is going to contribute for a Hamming distance, and this one is going to contribute for a Hamming distance. Okay, and for this zero, this one is going to contribute for a Hamming distance, and this one is going to contribute for a Hamming distance. So basically 2 into 2, right? That is the number of zeros into the number of ones. So is it clear now, Suraj? Guys who are new to this channel, just subscribe. It will be better for me. And that's it. Yeah. Okay. So let's go with the code. Okay. So then I'm taking the answer as 0, and then I'm going for, like, I'm traversing throughout the whole thing, and this x is basically the number of extras. Okay. And what does extras means? Extra is equal to the number of question marks. Okay, number of question marks. Yeah, welcome, man. So extras are actually the number of question marks. How we are finding the number of question marks? The number of question marks means the m minus AR of I plus AR of BR of I. Okay. By using that, we can do what? We can just find the number of question marks. Okay. Okay, because m is the total number of cases, right? So from that we can just subtract it. So that is what we are doing for the finding the number of question marks. Now we know one thing, that for the number of question marks we can either write 0 and 1, right? But for the remaining positions, they are fixed. They are fixed to either 0 or 1. So if we know that the number of zeros, we know that we have to make it m by 2, right? It was given, like I told you just right now. I just told you about this thing, right? This n by 2. Basically it is not n by 2 in this case, because this is just, we are considering m. Okay, so basically if it is lesser than m by 2, what we can do is, from that, so basically what we can do is, from that m by 2, from that extra, I mean, from the extra, I can just contribute as much as possible to make AR of I m by 2, right? So that is what we are doing. So whichever, like m by 2 minus AR of I is, just wait, okay, just wait a minute. I'm so sorry for the interruption though. There was some glitch from my side, so I was just fixing it. Am I audible though? Yeah, I'm audible. Okay, so I'm just taking, like, m by 2 minus AR of I basically tells us, like, how many we need to make m by 2, how much we need to add to AR of I so that it becomes m by 2, and x is the number of extras. So whichever is minimum, like if, let's say, for making m by 2 we need some number of elements, but we don't have that much of extra, that much of question marks, so we can't make it. So whichever is minimum, we are going to add that to it. Okay, and then from the extra we are just going to remove those, like whichever we have used. Okay, this is like removing used from extra. Okay, the same thing we do with BR of I also, and then we are just making answer plus equal to AR of I into BR of I. So as I told you in the as I told you. Okay, so just confirm if this is okay and this gets accepted. Okay, so if this is clear, is this clear? If this is clear, then only we will go to the next question. Okay, that is the anti-palindrome queries. You don't need to think about this, because I think this is a glitch. It doesn't get fixed. I'll explain you the whole thing. Okay, you don't need to worry about that. It got accepted. So if this is clear, then only I just go to the next problem. People who are watching this, I'll just request you, please like and subscribe. Okay, so since there is no response from you guys, so I'm just assuming that it is clear, right? Anyways, guys, just be a little bit interactive so that it becomes better for me. Okay, so let's go with the next problem, that is the anti-palindrome queries. So this problem, it states that you're given an array B of length m, and it is called an anti-palindrome if no pair of its opposite elements are equal. Okay, so what does opposite element means? So let's say if you're given like a string or whatever array can be, over here it's an array 3 4 1 2 3 4. So basically, if there's a mirror, it will be over here, right? And what does palindrome mean? It means that this and this elements are equal, this and this are equal, this and this are equal, and this and this are equal. Okay. And what does anti-palindrome means? Anti-palindrome means that for every specific positions, all of them are not equal. So what is the difference between anti-palindrome and not palindrome? Not palindrome will be like if not all of them are equal. But if all of them are not equal, okay, you have to understand this. This is a kind of word play. Okay. Basically, if let's say if this is equal, this one is equal, okay, but other ones are not equal. Okay, other ones are not equal. So it won't be a palindrome, right? But since at least one is equal, then it will be it won't be an anti-palindrome. Okay, it won't be an anti-palindrome. Anti-palindrome will only satisfy if all of them are not equal. Okay, so that's it. If all of them are not equal, then it's an anti-palindrome. So I hope this anti-palindrome thing is clear. So what happens is, basically you're told that you're given a array, and for every specific query, the query is going to give you a query of such, let's say a query of the sub array. Okay, the sub array, and L comma R. The query is in the form of L comma R. You can see that L and R is there. So basically the queries are like L comma R. Okay, and for all the positions including the L and R, if we can rearrange them in such a manner that it is anti-palindromic, and no matter how many times we perform a cycle on it, it will remain anti-palindromic, then only we can say that it is a beautiful subarray. Okay, or is it a beautiful, whatever it was given, okay, then only we can say that it is a beautiful subarray. And if it is a beautiful subarray, then we write yes, otherwise no. So let's go with this. So I'll just explain you this thing. Okay, not till over here. So I'll just explain you this thing real quick. So if we are going to go for 2,3, okay, if we are going to go for 2,5, if we are going to go for 2,5, it means that this thing, okay, this thing. So over here, if we draw a partition, this and this are not equal, right? Both of them are not equal. Now 2 3 1 3, right? 2 3 1 3. Now this is a anti-palindrome perfectly. Now what if we remove this 2 and write it over here? That is perform a cyclic shift. Then also we can see that this and this are not equal, right? Now let's say what if we remove this and write it over here? Then also it is then also it is anti-palindromic. And if we go for this and write it over here, then also it is anti-palindromic. If we rewrite this and write it over here, which gets us back to the original subarray. So this is also anti-palindromic. So no matter how many shifts we are performing, it is anti-palindromic. So this is going to give us the answer of yes. Okay. Now if we go for 2 comma 4, that is 2 3 1. So no matter whatever, however you may rearrange it, okay, since it is of length odd, since its length is odd, okay, this length is odd, so we know that the middle element, whoever like reacted a love, thank you, okay, I love you, bro. So basically we know that if this is something like this, so the middle element is where the mirror will be, and this element will always be equal to this element no matter what. So it's a direct no. Okay, so if the length is odd, it's a direct no. And over here you can also see that now the length is even. Okay, now the length is even, that is 1 comma 2, that is 2 comma 2. So no matter however you are going to like rewrite 2 comma 2, it will be always 2 comma 2, right? Because this thing, it is always 2 comma 2 2. Okay, it is 2 2. So this is a palindrome itself, right? This is a palindrome itself, so you can't take this, and so this is a no basically. But if you're going to check for 1 comma 4, that is this 2 2 3 1. Okay, 2 2 3 1. Now you may say that this is an anti-palindrome, but if we remove this 2 and put it over here, sorry, and put it over here, then it's a palindrome, right? Then it's not an anti-palindrome, because this and this are same, right? But this is not so. Okay, this is not so, because we were given the freedom to rearrange it, right? So if it is 2 2 3 1 and we rearrange it like 1 2 3 2, we can see that it is similar to this format, right? 1 2 3 2, that is 2, 3 gets replaced with 2, 1 gets replaced with 3, and 2 gets replaced with 1. So basically both of them are having the same pattern, so we can say that it is an anti-palindrome. So it's an yes. So in the last case we had to rearrange it. Okay, now if we look at the problem, it was given one thing clearly. It was stated that a of I is lesser than equal to 3. Okay, it is from 1 to 3, so that means the elements can be 1 2 or 3. Okay, this is clear, right? Now our main aim is to find whether in a specific range we can say it is going to have a rearrangement which will yield a beautiful subarray. I mean, which will yield an anti-palindromic subarray, which whenever we perform a cyclic shift on that, it will remain it will remain anti-palindromic. Now since we know like there are only 3 elements, so for every specific subarray we can find out the frequency of all these elements by using prefix and suffix. Okay, by using prefix and suffix, or let's not even suffix also. Okay, just using prefix we can find out prefix frequency. Okay, you can find out what is the number of winning world finals question. Winning world finals, this question, I don't know, like I didn't get you. What the heck is happening with my typing skills, man? Okay, so basically we know that prefix frequency, we can, by using the prefix frequency we can find out for a specific subarray. Okay, let's say we have an array. So for a specific subarray we can find out what is the number of ones in it, what is the number of twos in it, and what is the number of threes in it. Clear? Now when can we say that it is a valid thing, right? When can we say that it is a valid thing? Now I can tell you the answer directly, then I'll just show you the proof. Okay, so the answer is going to be whenever the maximum frequency, okay, maximum of frequency, what do we mean by frequency? The frequency, maximum frequency of 1 or 2 or 3 basically whichever gives us the maximum frequency, okay, 1, 2 or 3. So when the maximum among these three frequencies, it is equal to n by 2, I mean not n by 2, let's say length by 2, okay, length by 2, then bro, you deleted the like, I didn't get you, okay, don't like, I didn't mean to like say you something, but I didn't get you actually, the world finals thing. Okay, today is the world finals too, I think, no? Anyways, people who are just new to this channel, just give me a subscribe and like this video, it will be really helpful, okay? So basically, if it is equal to length by 2, then only we can say that it is a proper thing. Why is it so? Because one thing we know, that if it is yielding a length that is odd, okay, then we can directly say that is a no. But if it is even, okay, if it is even and we place at the even positions, if we place the same number, or let's say for at the odd positions we place the same number, even or odd, it doesn't matter, then those numbers are going to be checked with some other number only. Okay, I don't know whether you're getting me or not. So let's say there is a array of size this is 4, right? 1 2 3 4 1 2 3 4, that is 8, sorry, not 4, 8. Now if we check the odd element, that is the first position, the third position, the fifth position and the seventh position. So these positions, if they are fixed, okay, they are fixed, and for the remaining positions it is like something, okay, it may be A, B, C, D, okay, we don't know, but it is not equal to X, we know this clearly. Now we can say that X gets compared to D, this X gets compared to A, this X gets compared to C, and this X gets compared to B. Okay, so we can only rearrange, wait, so sorry, just wait, I'll just cut off the chat and just read off it, okay? See, so till the chat loads, I can't see the chat, so I'll just check it on my phone. Hi. I'm so sorry, okay, I just got disconnected. No, I'm perfect. Okay. I mean, not I'm perfect. My live stream is perfect. Okay, so let's get into it. Now, as I was telling you, that if the X is placed at odd positions, that is first, third, fifth, and seventh positions, so it gets basically checked with the elements which are not at that position, right? So it is only possible if this X, for the remaining elements, they are not equal to X. Okay, so this A, B, C and D, they are not equal to X. So basically that means that whatever the frequency of the maximum element, because from here we can say that, let's say if this A, B, C, D are same, okay, so that then it will be A, right? Then also what is the maximum frequency element? That is X, right? It is X, no matter what. So if the maximum frequency element is equal to length by 2, then we can say it's a valid thing, right? Is it clear? Like this logic, is this logic clear? Just tell me if this logic is clear or not, okay? Based on that, I'll just go to the code. So I'll just start explaining the code. So if anyone tells me that it's not clear, then I'll just go to the explanation, okay? So over here, what I'm doing is basically I'm taking, so just let me, I'll also write over here. So I'm just taking an array and taking its input. dp1 is basically the number of ones, dp2 is basically the number of twos, and dp3 is number of threes. What does dp means? dp is prefix frequency, okay? Prefix frequency of 1, prefix frequency of 2, and prefix frequency of 3. Clear? And if the first element is 1, so we know that we have to update the value of the frequency of the first element. Okay, so basically based on that we just update it, and then for the remaining element we are just doing the same thing, that is dp of I equal to dp of I minus 1. That is the prefix operations. You know what the prefix operations are. It's like it copies the previous element and checks if the element at that position belongs to that, then only it goes with plus 1. Okay, instead of getting for plus equal to 1, you can also do like this. Okay, plus 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 plus, this also works. Okay, this also works, but for now I'm just taking it as plus equal to 1 only. Then for every specific query I'm taking the value of L comma R, and since it is given that it was 1 based indexing, so for my benefit I'm just making it minus minus. Okay, so that it becomes 0 based. So I'm just converting it to 0 based. Okay, now we know one thing, that as I told you, if the length is odd, it means that R minus L plus 1 is odd, and if R minus L plus 1 is odd, it means that R minus L is even. So R minus L, if it is even, then we can say directly that it's a no. We don't need to even consider how many 3s, 1s or 2s are there. We don't need to consider, right? We can directly say it's a no, because the middle element will be the partitioner. The partition will be the middle element, and the middle element will always be equal to the middle element, right? So that's it. This part I think this is clear. Then I'm taking A1, B1, C1, A2, B2, C2. Now what are A1, B1, C1? A1 is basically the number of ones that occurred before L. B1 is the number of 2's that occurred before L. And A2 is the number of ones that occurred till R, and this is till R. Okay, this so A2, B2, C2 are the number of 1, 2, 3 which occurred till R, and A1, B1, C1 are the number of those elements which have occurred before L. Okay, so we can see that till R we have done it, and for before L also we have done it. Okay, before L also we have done it. Then we are just checking, like we know one thing, that if we know that till this position, let's say we have an array. Okay, let's say we have an array. So we know that there are a specific number of ones till over here. Okay, till over here, and a specific number of ones till over here. Okay, so for this range, for this sub array, we can directly find the number of ones by subtracting the orange one with the blue one. So that's it, what we have done basically. Okay, so we have subtracted it. This was not necessary. I just wrote an extra code. This was not necessary, this is not needed. Then I'm just taking an array of size 3 and taking like the values of A, B, C and in it. Okay, you may say that this is a very illogical thing, so we could have also done it like this. If D is equal to maximum of A comma maximum of B comma C, this is also a valid thing. So because we are just taking the maximum thing. Okay, so I'll just rewrite it like this, so it will be better for you to understand. And then R minus L plus 1 is basically the length. Okay, basically the length of the whole sub array. And if we divide it by 2, as I was telling you, this thing as I proved you. Okay, so based on that we can say that if it is equal to that, if the maximum frequency is equal to the length by 2, then only it's a yes, otherwise it's a no. Okay, so I hope this is clear. I hope this is clear with you guys. So if this is clear, just write it in the live chat. Okay, is this clear? So if this is clear, just write in the. So I'm just assuming that this is clear. Okay, since there is no response from you guys, so I'm just assuming this is clear. So let's go to the next question. Okay, completion easy. This is the easy version of the problem. Here it is guaranteed that P of 2i, which means that every element at even positions are same. Okay, I mean not same, it is equal to 0. Okay, so you're given a permutation from 1 to 2n, and for each of its missing element It is represented by zeros. We have to maximize this thing. Okay, this thing we have to maximize this, and we have to find out in like how many at the zeros we can write anything, right? So at the zeros we can write anything. So we have to find out how many permutations or combinations it is possible, like how many things that we can write in all the zeros. Okay, for all the zeros, how many things we can write it over there. Okay, so it will be better if I tell you this. Okay, using an example. So let's say 40 this thing. Okay, may I know your Codechef handle? Yeah, it goes like this. Okay, it goes like this. This is my Codechef handle. But this thing, the contest that I've given, this is from other account. Okay, this is from another account. Because I don't use this account anymore. This Griffin codes. I'll use it when like I feel like using it. Okay, so that's it. Okay, so let's say we are just copying that. Okay, so this 4020, right? So if you look at the question, it was given that it can be either 356 or 365, right? So these threes can be, it can be 3, 5, 6. Code forces. Code forces I don't remember actually. I don't remember. Okay. Like I have too many accounts on code forces, so I don't remember at this moment. Okay. Just ping me up on Discord or LinkedIn. I'll just tell you. Okay. So one thing that it was like we can write 356 or 365, right? So there are two possibilities, and for both the possibilities, the value of that thing that it was given, P1 minus P2, P3 minus P4, that is maximized. Okay. Now we can see one thing, that this 5 and 6 can, what's your rating? Codechef, I'm just like not that good. You can see that. Okay, this thing. It's 1919. But the other account, I think it's 196 something, 1960 or something like that. Okay. So basically, you can see that whenever we are just reversing this, it is because 5 minus 1 and 6 minus 2. If we add them, it is also equal to 6 minus 1 and 5 minus 2, because both of them are greater than these two numbers, right? Both of them are greater than these two numbers. So this is very much clear that for anything that is greater than that, so let's say we had 1 and 2. Okay, so for 1 and 2, we can write 5 and 6 and we can reverse them. So now if we look at it very carefully, so there is 1, 2, 3, 4, 5 and 6, right? Total, the whole thing. So it is 1, 2, 3, 4, 5, 6, among which 4 gets paired with 3, 1 gets paired with 5, 2 gets paired with 6, but 1 can also be paired with, I am beginning in the CP, I need to guide this and roll back. Okay, just wait a minute. Okay, I'll just explain this question and then I'll just get back to you. This can be paired with any one of them, 5 or 6. Why is it so? We can see that 4, so anything from the next part gets paired to something in the previous part. This 5, it gets paired to either 1 or 2, and depending on that, the 6 is also get paired to this 2 or 1, right? So now this is very much clear for you guys, I think. Subscribe to your channel. Thanks man, thanks. Even share it with your friends, okay? Who just want to learn CP, just share it with your friends also. It will be helpful for them as well as motivational for me, because I'll get the motivation to make more videos. Because you know what, like if I feel like making if I feel like selling my codes, you know that on Telegram there are people who are selling their codes, so I'll obviously earn more, right? I can earn like around a lot because I complete those codes well beforehand, so I can sell codes out there. But still I prefer that no, cheating shouldn't be appreciated, so I just upload my videos after the contest is over, okay? And I try to explain people out there. So people who are just genuinely want to learn CP, I'll just suggest you that please suggest them my channel, okay? It will be helpful for them. Like all the elements of the first part are connected to the element of the second part. Why is it so? Because it was given that the second positions are always 0. So for every specific pair, at least one is given. For every specific pair, since the second one is 0, so at least one will be given. So this can be either 0 or a number. So if it is a number, that means only one is given, or if it is a 0, it means that none of them is given. This is for a pair, okay? What a pair is basically, like if you look at this, we are just dealing with pairs only, right? So that's it. So you get it, right? Now you have to think about a little bit of complex calculations, because this is not that easy. Like if you like this thing, you know, like from this you can do what? You can just find the maximum value, but you don't know how many possible values it should be there so that the value is maximized. Okay. Now if we look at it from these, so 4 1 2, right? 4 1 2, basically 1 and 2 are used up and 4 is used up. So from the first part there is 3 and from the second part there is 2, right? Now these 2 can be like in any position, and this 1 can be in any position, right? Like I don't think like it will be like, I'm just telling you clear or not, but I don't think it will be clear for you. Just be honest if it's not clear, okay? Okay, so this is clear, right? I mean, I'll just explain it again only. So let's say like, so this 3, it can be paired with only this 4, and this 5 and 6 can be paired with either 1 or 2, right? So basically for this, it means that the number of permutations will be 2 factorial. And for this, since there is only 1, so it will be 1 factorial. Now if we multiply them, we get the answer. Okay, so if we multiply them, we get the answer. That is 2 factorial into 1 factorial, that is 2. Now for this, if we are going to copy this, so I'll just copy this and explain this also. Now let's say we have this. So if we write 1, 2, 3, 4, 5, 6, 7 and 8, right? Among this, 8 is there, 5 is there and 3 is there, and the partition will be over here. So how many are over here? There are 3, right? So there are 3 over here and 2 over here, which makes it 3 factorial into 2 factorial, right? But if we notice one thing, that this position, it could have been a number, but it is 0. Okay, it could have been a number, but it is 0 for now. Since it is 0, so we can place anything over there. Okay, but for now we are not going to focus on what that anything is. Okay, we are just going to focus on what this is. So that is 3 factorial and 2 factorial. What is it? It is 3 into 2 into 2. That is 12, right? That is 12. Now, for every specific elements, okay, for every specific elements, whatever the number is, we can just make it 2 to the power k. Why is it so? You may ask me why is it so? Because let's say this two are zeros, okay. So what is 2 to the power k? That is 2 to the power 1, it is 2, right? Why is it so? Because let's say we have a number over here, x, and a number over here. We can put, okay. Now, x minus y and y minus x are same because it is the absolute value, right? Now, since both of them are same, so we can either write it as x comma y or y comma x. So there are two possible values. Now, let's say there are 4 total, okay. Let's say we have got 4 total. So for these two, we can write it as 2. For these two, we can write it as 2. And for the total, we can write it as 2. Right? So what is it? It is going to be 2 to the power 3. That is 16. Is it clear? Is this part clear? Like it is kind of a divide and conquer thing, okay? It is kind of a divide and conquer thing. So basically this 12 and this, from these two zeros, we can get 2. So 12 into 2 is 24. And for the last part, as I told you, that this is 0, 0, 0, 0. So it is 16, as I told you, 2 to the power 3, right? So now we'll just go into the code. So if you guys have any problem, just be clear, okay? So that I'll just explain you what is it, if there's any problem. But this part is very illogical. It was not needed because I was just concerned about whether we need any NCR thing or not. So I just used a little format thing, but it was not needed actually. So I'll just remove this thing out of it. Okay, so I'll just remove this thing out of it and I'll just explain you, okay? So I'm taking, this is the test cases, then I'm taking the value of n, then I'm taking an array. So this was not needed actually, this was not needed also. Then I'm taking x and y. So now you'll not get what x and y is, but you'll just get it eventually. I was able to solve only first two questions. Then just rewind the video and watch the explanation till the next two questions also, okay? So basically, like this is frequency. The frequency means that whichever position they're present. So we are just taking out the frequency of that. Now since we know that the second element is always 0, so we don't need to consider about that, okay? So we are just, for every specific n, we are taking one element, okay? And we are checking if it's a 0. If it's a 0, we are just adding that to y, because y is something that we can modify, okay? And if it's not a 0, then we are going to make it x plus plus, okay? I mean frequency of x plus plus. Then I'm taking the value like sin of x. This is just the zeros, okay? Since it was given that they are zeros, so we don't need to consider it because we know already it's 0. So we are not going to look into that matter anymore. Then, as I told you, I have to find out, I have to find out how many elements are there in the first half, right? So in the first half, that is A is the number of elements in the first half. So for first half, it means 1 to n, how many elements are there? And in the second half, how many elements are there, okay? Once we know that, then we can say that we can just make the factorials. What is factorial? Factorial is multiplying from 1 to n minus a. Why is it n minus a? Because if a elements are there, and there should be total n elements, and we need to find how many elements are not there, it means n minus a. Okay. So basically for n minus a, I am taking the factorial, and then for n minus b, I am taking the factorial. Always remember to make the mod, okay, because that is very important. It was given in the question. So then you take the mod, answer mod is equal to this. This condition is not necessary. I was just checking if there is any bug or not. That was not necessary actually. Then for every specific element from 1 to y, I am going to make that into 2. Okay, that specific element into 2. That is 2 to the power k. So I'm just assuming that, is it clear? Is it clear for you guys? Just tell me if this is clear, okay? just go for the editorial of this code. Okay. Just wait, I'll just put it over here. Put it over here only, it's better for me. Let's get in the solution. This is a little complex. I think I'll just leave this question like for now. Okay, I'll just leave this question for now. Now the last two operations are obviously complex because, like, if you see that there are only 44 operations, like, I mean 44 people who have done it. Okay, so if there are only 44 people who have done it, so I think it's like it's good. It's a good problem. Okay, but it was completely like normal mathematics only, similar to that, similar to the previous one. Okay, it was normal mathematics only because we can see that it's x factorial into y plus z factorial. I don't know what the heck y plus z is. What the heck is y plus z though? I don't know what the heck is y plus z is, but I know what x is basically using that. So you can look at the code also. You can look. I'll just go for the tester's code. Now, the tester's code is very long, so I won't look at it. Look at the editorial's code only. Yeah, this is shorter. So he does it. He does it. What is x and y? I don't know. So he's just counting the number. Okay, from begin of mark to begin of that, answer equal to 2ll into answer, that is for the empty number of empties. He's just checking it, and then he's going for it. It is very similar to the previous problem, but it needs lot much more computational mathematics. Okay, so that's it from my side. So I'll just end the video. So before ending the video, I'll just ask you guys, is there any problem? And whoever was viewing this, thank you for watching. And whoever will be like watching the live stream later on, it will be very helpful if you can subscribe my channel, like this video, share it with your friends. I mean, share my channel with your friends who are into CP. Who are not into CP, you can share it with them also, because it will gain me subscribers and like give them the interest to come into CP. Nothing more. Okay, so that's it from my side. Good night. Take care.